Let's take a look at another example. Again, we're dealing with a non-standard normal distribution. This time we want to find the probability that x is greater than 2.6. Since it's a non-standard normal distribution, we start the same way. We calculate the z-score. Z equals, formula is the particular value minus the mean over the standard deviation. The particular value we're interested in, the boundary value, and the probability we're calculating is 2.6. Subtract the mean. Looking at the notation here, the normal distribution has a mean of 19.4 and a standard deviation of 10.3. So minus the mean of 9.4 divided by the standard deviation of 10.3. So let's calculate that and get our z-score. Notice I'm careful to put my numerator in parentheses. I want that whole numerator to be divided by 10.3. Without those parentheses, I would not get the same thing. In that case, because of order of operations, only the 19.4 gets divided by 10.3. Only after the division do I take 2.6 minus that. That's not what I want. I want all of this, the 2.6 minus 19.4, all of that divided by 10.3. So watch those parentheses. Okay, my z-score is negative 1.631068. Okay, so that means that in our current normal distribution, the probability that x is greater than 2.6 is the same as the probability in a standard normal distribution that z is greater than that z-score of negative 1.631068. Okay? What does that look like? My mean at 0. Negative 1.63 is less than 0, so somewhere over here. And I'm interested in the z values larger than it. So this is a sketch of what this probability looks like in the standard normal distribution. I am calculating the probability in the upper tail, not the lower tail. So I can't just use the p-norm function as is. If I did p-norm q equals negative 1.631068, or p-norm q equals z, I can use z because I've stored that z-score in variable z. That would give me the probability in the lower tail, to the left of that z value. It'd give me this probability, or this area. Okay? That's not what I want. So whenever I calculate the probability in an upper tail, remember I first calculate all 100% of the probability, right? The total area under the curve, 1. And then I subtract out the part that I don't want. This part over here, the part to the left of negative 1.62, that's exactly what I don't want, right? So I take everything under the curve, and then I take out what I don't want, and that'll leave me with this part, which is what I do want. Okay? So evaluate this. This is how we always calculate probability when we're calculating it in the upper tail. My probability is 0.948562. So the probability that a randomly chosen x would be greater than 2.6 is the same probability that a randomly chosen z in a standard normal distribution would be greater than negative 1.63, which would be equal to about 95%.